back. Been a while. Sorry, I've been away. We've been busy making our new book called You Are the Hero, which is all about the elements which make up your body. But it's got a couple of holes in it, so you have to read it in a mirror because it's written in reverse. Anyway, our next element is zirconium. So if we pull up the card and its atomic structure, it's number 40. ZR is its symbol. Now, zirconium was discovered in 1789 by a German called Kapa, and he discovered it in Sri Lanka. He was studying the mineral zircons, which is a crystal, which we'll come back to. And it's a tough crystal. The actual element zircon is tough, but when you join it with oxygen over here, these two, they make a crystal called zircons, which is an old Arabic word meaning zargan, which means gold-like, because the best zircons had a sort of like a yellowy color. They were the ones sought after, and it's been known for thousands of years, since biblical times. Zircons have. And it's tough. If you remember the last video I did with titanium, I was grinding up titanium to show you how it makes a spark, because titanium and zircon, they are reactive. They will burn if they're ground up into a fine powder and set light to them. They use them in fireworks. In fact, this whole area is really tough. This is like the super tough superhero area of the board, because you've got things like scandium used to tip missiles punching through ice launched from submarines. You've got titanium, which is the strongest for weight element metal that there is. Vanadium, niobium, amazing what's called tensile strength. So they can withstand being pulled. Chromium, the hardest metal on the of the elements. You've got molybdenum used to make swords, as is vanadium. Tungsten, the highest melting temperature, and quite a few of them, like yttrium and rhenium over here, osmium used in bullets. You've got a real sort of like tough, strong area of the board here, especially when they are mixed with alloys. So they're made into an alloy by mixing it with another element to make it really strong materials. And you can see on the card, if we pull it up here, we've got some crystals hidden on these sort of arms and legs. Those are the zircons. Now, zircons you can be found on some beaches in the world. And most of it's mined in South Africa over here and Australia. But zirconium, they have discovered it on meteorites which have hit the Earth, and it's been discovered on moon rock, lunar rock, and it's in suns, including our own sun, found in stars, including our own sun. So next thing to have a look at is this. He's holding a rod, a great big rod there that's radioactive. Now there are radioactive elements on this table. They're sort of indicated by, if we pull them up quickly, radon, astatine and polonium over here. Bismuth is a little bit radioactive. You've got technetium, and over here francium and radium. Now they're all radioactive. They have that sort of multicolored glow around them. Now zirconium and hafnium, they both are holding something radioactive, because zirconium's superpower is that neutrons will go straight through it. It's transparent to neutrons. What does that mean? All right, back to our atom. Radioactivity is when this central area here, the nucleus, deteriorates, it breaks apart, it decays. And when it decays, these neutrons, they can go wandering off, and they can cause a chain reaction. And in a nuclear power station, they use that. So you've got your nuclear power station, you've got your something called uranium. It's another element, much further on down the table, that decays, that heats up water, which makes steam, which runs a turbine, which makes electricity. That's how your nuclear power station sort of works in a nutshell. But these neutrons need to be contained somehow in the uranium rods, and they put a cladding, they put a coating of zirconium around the rods to sort of like keep it safe, to keep it contained. But they don't stop the neutrons from wandering off. So that's why he's radioactive. Now going back to crystals, crystals of which zirconium mixed with oxygen making zircons is just one example. There's all sorts of crystals, but they have a superpower. Crystals, when you bend them or hit them, they will make electricity. And it works the other way around as well. If you introduce electricity into the right crystal, it will bend. So you're turning electricity into something mechanical, or mechanical into electricity. And they use it for all sorts of things. Sensors to turn off lights. Well, that's dark. Cool. Submarines in sonars, which is the noise that they make to help discover other submarines or where on earth they are. It's used in clocks, all sorts of sound equipment. So crystals have this superpower. It's called piezoelectric power. So it's used in all sorts of technology and lots of applications. Now, a good example of this piezoelectricity is a barbecue lighter, which you just pull a trigger and hopefully a flame comes out the top. Now, inside here is a crystal. And what happens is a series of events which ends up with a flame. And one is you squeeze with your finger a spring-loaded hammer, which then hits a crystal, which produces a current, which makes electricity, which makes a spark, which at the end of the reaction produces a flame, which comes from a chamber of gas inside here. So some of you will have that in your house. Squeeze it, you're making piezoelectricity. And are there crystals in superhero films? Yes, there is. There's loads. We've got, of course, Thanos with his elemental crystals in his glove. You've got Superman. Superman not only lives in a crystal house, or he's got a crystal apartment up in the Arctic, I think it is. And he also has this really cool crystal spaceship. So there's crystals in all sorts of superhero movies. And of course, not forgetting this fella, Olaf, from the film Frozen, of course, where an amazing palace, crystal palace, gets built. And Olaf is made of snowflakes, is he not? A snowman. And has he got superhero powers? I should say so, yeah, but I'll leave that up to you to ultimately decide. So yeah, of course, snow, beautiful snow, is a natural crystal. Other ones include things like salt crystals. So crystals are all the way around us, everywhere, everywhere. Crystals. So next time, the next video is going to be about hafnium. They're closely related, and I'll explain why in the next video, which hopefully we'll do pretty soon. I won't leave it so long. Thanks for looking in. Check out elementskapa.com if you want the free, all this we have as a high definition artwork, so you can, I'll just email it to you for free, which is great. And if you could subscribe and like, that's awesome as well. Okay, thanks a lot. I'll see you next time for hafnium. Take care. Hope you're safe.